Hello, everybody. My name is Rahul Miglani. I'm heading the DevOps practice here at Noldes. I am a VP Engineering by designation, and agenda for today's session is observability at scale. I hope you're already aware of what is observability, but if not, we will cover the basics as well before moving into more complex things. So sit back and relax, and I hope this would be a fruitful session for all of you all. Before we proceed, let's know about Noldes. Noldes is a team of passionate technologists with a product mindset who work along with businesses to deliver solution at the speed of competitive advantage. Our main capabilities are around reactive products, Internet of Things, microservices, and API, data science, data engineering, and DevOps. We also have our strategic partnerships with Databricks, Lightband, Confluent, Snowflake, and many more to deliver more value to the client. I am Rahul Miglani and I handle the DevOps practice here at Noldes. Quickly moving to the agenda for the day, we will look into the basics of what is observability in DevOps, what are its different components, what is it made of, what are the actual benefits of observability, and how we fall into pitfalls while delivering or while trying to measure observability. We will also look into observability at scale and what are the best practices around setting up observability. Uh, Observability is actually the foundation of reliability. It is the stepping stone of site reliability engineering. Observable systems provide sufficient information about the internal as well as external state of an infrastructure through outputs such as matrices, alerts, logs, dashboards, and traces so that SREs can determine if a system is healthy, providing expected service levels to the user, or let us say to optimize performance and behavior. As written, when things go wrong, observability enables SREs to diagnose and fix issues when they arise. An optimized state of observability would be self healing, wherein an issue occurs, the system is capable enough to fix it and reload it, be it doing a zero touch deployment. In more complex systems, the higher user expectations are over reliability, the more important it becomes to invest in advanced observability methods to reason about what is going on in our infrastructure system, be it fintechs or be it the new tech giants. They have all a very high site reliability engineering teams as well as observability teams. So the goal of observability is to deliver a unified plane that spans on-premise as well as cloud computing environments, which actually experience high availability, a global view of metrics, logs, and trace information with features like dashboarding, alert management, incident management, and many more in ITL range. So this approach is similar to common data security features and compliance controls. With observability, they all become easy, right? Moving on, as we have seen that applications have gone from being monolithic to being more distributed in nature. Now, this makes it difficult to pinpoint error because it cannot be just achieved by just monitoring, right? So, observability tech stack helps you solve this complexity. First, it lets you understand the internal state of application by observing, and then it traces it, and then it identifies where the problem has happened. So before we move on to the components of observability, we have to understand a full stack observability, from where to start and where to set up observability. Now, full stack observability includes the standard elements of observability plus additional features that enables you to monitor all the aspects of your system across applications, across networks, and across infrastructure. Now, full stack observability takes an important step beyond traditional monitoring, right? So, this approach provides visibility, insights, and actions from the API all the way back to the bare metal across all data types, right? Now, full stack observability provides a comprehensive view of your distributed environments, allowing you to determine where a system fault has originated from. Only then you will be able to resolve the issue without any delay. You can start recording how different elements of complex system interact, and this practice will enable you to resolve performance issues, right? Now, full stack observability, there are softwares, there are tools, but most important is to understand from where the issue has originated from. Only then you will be able to utilize the benefits of observability. Only then you will be able to enhance your alerts. Only then you will be able to improve your system visibility. If we talk about latency and speed, the problem is diagnosis, because the resolution is always provided by the SREs. But the main problem is diagnostic, right? Providing developers with an enhanced global view of their entire system architecture, including the third party application and services, help them gain a better understanding of the system performance, which can lead obviously to improved product design, and obviously it will solve your latency and development speeds as well, right? Now, where and how you collaborate on that? For that, you have to give visibility to your SRE teams, starting from your bare metal to your compute, which can be either ways, or on hybrid or on cloud infrastructure. Then you go to virtualization level, and then to your OS level. Above that can be your platform. It can be your applications. It can be your ports, containers, any tool like Kubernetes. And then on top of it, you can have your transaction matrices setups. As soon as SRE teams have the visibility of full stack observability, only then they will be able to utilize its benefits. Now, moving on to the components of observability. For proper observability of a DevOps model, there are some basic components that we all should know. Looking at the slide, you would see there is logging, there is tracing, and obviously there are matrices, right? If you see, metrics are a set of data that show the performance of a system. We all know that, right? They are collected over a specified period, which could be your days, weeks, months, or even years for bigger complex systems. But what do you get out of them? You get matrices over a continuous point in time overview of the system, right? Now, this enables teams, especially SRE and DevOps teams, to spot specific trends as regard to the performance of the system, right? And then it makes it easy to point out where the problem originated from. Perfect. It can be, for instance, your website traffic, or your turnover rates, or your user rates, or even the memory usage of the system, right? It becomes easier. Now, this is where we can differentiate matrices from logging and tracing. Now, what are logs, or what is logging, or what are event logs? Now, event logs are simply a written record of events ongoing in the system. Who came in, who went out, right? You can get this component of the observability from the records of incidents, right? Now, logs gives you a view of events and errors or even warnings, right? It gives you context to the problem at hand. Now, event logs can be different in terms of how they are originated and how they are stored, right? It can be in form of arrays. It can be in terms of time series databases, right? How we put them, whether it is a columnar data or a row-wise data, right? So that is different for different systems. Most important point of observability is tracing, which is complex, but it is if you understand the basics, it becomes very easy. Now, traces are a major pillar of observability because they make the system under observation more visible and understandable. How? For example, a trace provides an SRE team or a DevOps team an overview of the system based on the request, or let us say the transaction made in the system, right? First, a request is made to the system and then it records the request flow, right? From one service to another or from one system to another, right? So that is why it becomes major because it tells you how the information has flown from one point to another. Now, tracing is achieved through a provision of detailed view of what happens in the various part of the system when a request is processed, right? So each component gives you a different type of output. That is why I say observability involves external system outputs to understand the internal system of your infrastructure. It can be very, very complex, but as long as you are measuring the request flow, your tracing will be easy, even though your infrastructure will be complex. Right? So these are the only main components of observability. There can be integration to the outside world, there can be integration to your own infrastructure systems, but end of the day, you can differentiate them into logging, matrices, and tracing. Now, let us have a look at a very simple observability pipeline. It is the most basic pipeline, but obviously it can be more complex depending on the architecture of your project. With an observability pipeline, what we do? We decouple the data sources from the destination and provide a buffer, which makes the observability data easily consumable, right? So this is the basic. And how a pipeline stream processes engine? It just unify the data processing along all types of observability. It can be logs, traces, matrices, events, and whatnot. We collect it, we create a data pipeline, and we then route it to how we are trying to understand it. Right? It can be schema agnostic. For example, we might be aggregating it with ELK or EFK, or we might be suppressing it, or we might be dropping fields, or we might be adapting it, right? Another area would be easily verifiable. How do we do that? We might ship it, we might ship the data, so that it is easy to test and visualize, and then how we deliver it, right? For example, everything might only depend on how easy or how difficult your data is. How is it nested? Whether it is JSON, CSV, or key value logs, right? Because data comes in all shapes. It can be ugly, right? So you should be able to easily verify what are the configuration you are likely to work with so that you can choose your tools, right? That is why logs, matrices, or traces data will come usually in from your agents, right? It can be logstash, ELK, EFK, fluent D, or collect D, or open telemetry. These are the three things you will probably use for metrics, traces, or logs, right? Then how you do you normalize your data? Now, data coming in will usually be in format native to the ecosystem. For example, it is coming from so Splunk, Elastic, Influx, OpenTelemetry all have optionated schemas. If you are dealing with multiple systems, as most architectures have it, you'll probably need to normalize to some common schema, right? Across different agents. It can be in form of arrays at the end of the day, right? And how you route it then at the end of the architecture, how you route it. Now, data intended for different destination will need to be processed differently. We all know that, right? So, our processing, the actual work is to aggregate, suppress, mask, drop, reshape, whatever happens in processing, and then put it in our pipeline, right? And after we have processed it, we come to the output schema. Now, data again needs to be reshaped to the destination system expected schema. Whether you are putting it into a database or you are putting into a dashboard, you must put it or reshape it to the expected schema. Now, what is the delivery? What is the alerting? Right? Now, most of the system can be shared or cannot be shared depending on the architecture. But for alerting, you'll probably have some lookups, right? And how do you manage it? How you are managing the configuration file? Data can be in huge size. So centralized monitoring and management are critical, depending on the size, right? Depending on the architecture. So, depending on the tools you are trying to use, for example, if you are using Splunk for order sample, send to Splunk and parse the data, right? And then end of the day, probably use Snowflake, Google BigQuery, right? Or let us say AWS, take or maybe on Windows system, Windows event logs, send full fidelity to your AWS S3, right? You can send subset minus irrelevant events. That is how you reshape your data, right? Because you cannot have petabytes of data and still call every data useful, right? You'll have to reshape, you have to suppress, you'll have to probably put it into a schema you understand, right? So, observability pipeline in the cloud is easy as long as you are able to understand from where the data is originating from, right? If you understand that, only then you will be able to lower the risk, make the result faster, because an observability pipeline in the cloud gives you the flexibility to handle everything without deploying different solution to the homegrown scripts to let us say consume different data sources, right? So that depends. Now your SaaS applications on cloud, you have the capability to handle connection from all your SaaS data sources. From there, you can transform the data to your preferred format, right? And then you can ship it to your logging platform. You have the choice of choosing your logging platform at the end of the pipeline, right? So this is how we look at architecture and we look at observability at scale. Because what happens with observability at scale is we end up having petabytes of data, and we also then need to see what data doesn't make sense to us or in what schema we need to put the data in. So choose very carefully the tools depending on where the events are originating from. Now let us say we have already set up the observability tech stack and observability tools and system in place. How they help us and where do they help us? Well, observable system help us indicating the outage or let us say service degradation. They also help us detect bugs and unauthorized activity. They also help us debug outages and obviously debug service degradations as well, right? They also help us identify long term trends for capacity planning and obviously for business purposes. For example, if you need to save cost, if you need to look at the costing or the forecast, it will definitely help you. It also helps expose unexpected side effects of changes, adding functionality or removing some functionality, because they'll be able to give you the trends. So, with all DevOps capabilities, installing a tool is not enough, right, to achieve the benefits. It can help you observe, right? So, monitoring system should not be confined to a single layer or a single team, right? All full stack architecture should have observability set up because it will help you improve the overall system debuggability. and at the end of the day you will be able to reduce the outages as well. There are few more important terms like TTR, time to restore, right? So there are few keys to effectively implement monitoring and observability tools. First, you need to uh, uh, know what is broken, and then you need to know where it originated from. The key metric in any event of an outage is service degradation or what is the time to restore, right? And a key contributor to time to restore is the ability to understand what broke and the quickest path to restore the service, which may not be immediately available. But let us say you are new to the observable system, you'll probably have to know the trends, probably have to look at the matrices in more detail, and only then you'll be able to do that. There are high levels of looking into a system, black box monitoring, where the system internal state and mechanisms are made known, or the white box monitoring, for example, which will tell you where they are, right? So um, obviously there are tools for different set of observable components. There are infrastructure monitoring, for example, with Nagios. There are log analytics with Elastic Stack, APM on dashboarding. For example, similarly, there will be tech stack for logging. Whatever suits your infrastructure, will probably be choosing that, and then you're tracing, right? So you'll probably have to carefully choose the component of observability which makes sense to your architecture. Now, can there be pitfalls while setting up observability? Yes, there can be. One could be uneven distribution of information. For example, you might end up uh, putting in a lot of stack from where the event is not originating from, but you will probably have little information from the source of the event, right? Or you might have a tool which has or which doesn't have the capability, or your alerting system is such that you have millions of alerts but you don't know on which alert to work on. Very common mistake is that you end up receiving millions of alerts and you have no idea on which alert to work and on and what alert to ignore, right? So when developing a system for monitoring and especially observable system, you should be aware that there is generally isn't a simple plug and play solution. Any monitor observability solution will require a deep understanding of each component that you want to measure, as well as direct manipulation of the code to instrument those systems. You'll probably have to avoid having a single monitoring person or a team or a tool, right? A common anti pattern is writing alerts in monitoring system is to attempt enumerate all possible error conditions and write an alert for each one of them, right? We call this cause based alerting, and you should avoid it as much as possible. Instead, you should focus on symptom based alerting, which only gives you alerts when a user is facing a symptom which is visible or is predicted to arise soon. You should still be able to observe non user facing problems, but they shouldn't be directly alerting on call engineers, right? So, let us say you should have only meaningful alerts which are symptom based, right? You don't want to end up receiving millions of alerts, right? There is nothing called as a perfect dashboard, monitoring dashboard, right? Yeah, no dashboard is perfect, right? But when building a monitoring dashboard to visualize metrics, uh, you should be creating a dashboard which is up to date, but also focus on the ability of team members to quickly work on resolving a problem. You know, you might end up having a dashboard which shows you something is red but you are not able to solve that problem. Then what is the use of that dashboard, right? So failing to separate out product or executing matrices where your revenue is blocked but you don't know what to do, right? In optimized level you might end up having self-healing architecture, right? Or zero touch deployment which works only on when a um, alert or a event has happened, right? So I can give you some best practices to follow. while setting up observability. But end of the day, you'll probably have to work on knowing your architecture first and what makes it work, and most importantly, how soon you are able to solve that error. You might have fancy shining dashboards for you, but if it is not making any sense in solving the problem, then what is the user benefit of that dashboard, right? So having said that, what are the best practices? What should you keep in mind while trying to create a highly observable system at scale where you have petabytes of data and millions of alerts, right? First of all, you need to see who, how, and when the changes were made to your monitoring or observable configuration. How many pull requests or changes per week are made to the repo? Do you have a daily job? Do you have a batch job? Do you have an immediate job? Or do you have a custom job which achieves that? When you do that, you'll probably have to count or create a matrix out of the alerts which comes out of your office hours. If you have a 24 cross 7 system, measure everything. What percentage of alerts are handled when nobody is around? How many of these are self healing? How many of these alerts do not require a manual intervention? How many of these alerts are resulted in revenue loss? Right? You need to create or get the meaning out of your alerts, which are specially out of hours. What is the team alerting balance? Who is alerted? When somebody is alerted? If you have teams in different geographical locations responsible for a particular set of service, are they really distributed or they are just common uh, uh, alerts which are being sent to everybody? Very important aspect is to measure false negatives as well as false positives. How many alerts resulted in no action? You need to know this, because if the system is working as intended, the alerts which are not actionable, which haven't helped you predict failures, they should be deleted, right? Why to increase the count of alerts? Similar is the case with false negatives. How many system failure happened with no alerting? Or the alert happened 1 hour later? Or the alert happened when everything was red? So, do you have system based alerts? You need to know your false negatives, man. Obviously, we come back to alert creation. How many alerts are created per week, per month, per system, per infra, per sub level, per team level, right? If you don't separate out these things, you will not be able to retrieve the meaning out of these alerts. And how the alerts were acknowledged, right? What percentage of alerts are acknowledged? And do they or were they acknowledged within your SLAs? Or they are coupled with some other alerts? Right, your infra alert might be just an alert to your dashboard. It just reads out your dashboards, right? You need to acknowledge when the alert happened. How many were of them were acknowledged? How many of them were not? Right? Does they even make sense to you? So, unactionable alerts, usable alerts. Do you have run books? Do you have dashboards? Do you have playbooks for them? You can give it to your ops team who can run your playbooks. What are the actions? So, as long as that is there, only then you will be able to control your MTTR and MDTI. Right? The bottom line is to detect, time to resolve, and impact. Right? So, by tracking all of these metrics, you'll start to gain a better understanding of how well your system, your observability systems are working for your infrastructure. Breaking these measurements down by product, by teams, by methods, by infrastructure level, or by the tech stack level will give you an insight not only to the health of their products but your own processes. It might be able to give you how your particular teams are performing, right? That is why site reliability engineering as well as DevOps teams are heavily dependent on these matrices. That is why we say at Knowledge, measure everything. Everything which is measurable, you should be able to measure it and identify the source and cause of problem. That is how highly optimized observable systems are created, even in the most complex of architectures. Right? So, to conclude, we can say measure everything, monitor everything, but gather only the meaningful, necessary data, even if that means you'll have to reshape the data. Focus more on essential things and fixing them if they fail. Avoid storing every log or data available. Rather, store those that give insights to critical events. Right? Put up alerts on all the critical events. Create data graphs that are easily understandable by everyone in the team. Only then you'll be able to work on. If you're able to understand data, only then you'll be able to work on its solutions. So I hope all this information has helped you in some way. There are different ways of doing observability on different set of clouds. Probably in next of our session we'll cover. We have already covered Oracle Cloud Observability. In next of few session we'll cover observability and logging or even tracing on AWS and Google Cloud GCP. Uh, I hope this helped you. If not, feel free to give us some feedback so that we can come up with more information around topics which are of your interests. And again, to end this session with, I would like to tell you all thank you. Thank you for attending this session, and we would like to, receive your feedback about what excites you and what more topics you would like us to cover. So here at Noldas, we can prepare those topics for you and present you in another exciting session. So thank you very much once again. This is Rahul Miglani signing off. Thanks.